Hello, Mario. This is a wee problem I put up on the board in some tutorials I was doing the other day. I put up one specific to each of the disciplines we teach: civil, electrical, and mechanical. So I put the problem up, but we didn't have time to go through them and just confirm the answers. So that's what I'm doing today. So let's first of all just have a look at this first one and see how we go. So the first thing we've got to do, I think, is understand the diagram. So here we have what we call in surveying. I'm a surveyor, which is part of civil engineering, sort of. So yeah, this is the slope distance. So we're asked the question, what is the horizontal distance? And the peg A at A is 106.4 metres above sea level, above mean sea level. How far above mean sea level is the peg at B? So these are our two questions. All right, so with the instrument which we're using, we'll call it a total station or whatever, we measure from there to the target, and that's called the slope distance. Now in surveying we always measure the horizontal distance, so we want to find out the horizontal distance, which is essentially there. And then we're also interested in this height as well. So that's there. That's the difference in height from the instrument to the target. So the target's held there by our chainman or field assistant and what have you. And the instrument is set up over the mark, and it's a particular height above the mark. And the instrument height, in this case, 1.8 meters. And our assistant is holding a target with a target height of 2 meters. Okay, so that's sort of explained our problem. So let's go now. We're all familiar with Sokotoa. So normally I would write down Sokotoa and identify all the things I know. I've identified all the things I know in blue. I did them in green, but since I'm using a green screen, they all disappeared in green, so I had to change them over to blue. So this is take 2 of this video, in case you were wondering. So we've got a angle there, 18 degrees, measured by our instrument. And so we can work out the sine of 18 degrees, the cosine of 18 degrees, the tan of 18 degrees, and various other trig ratios, should we so desire. So that's good. Now, well, we also, and I'll show you this here, we know the slope distance equates to the hypotenuse of our triangle. The horizontal distance is the adjacent, and the difference in height, delta H, the opposite. And they're the two things that we don't know, and I've shown those in white. So we know the hypotenuse, and as you can see there, for both sine and cosine, we know 2 of the 3 things, 2 of the 3 elements of the equation or the ratio. So we can work out the third. Right, so the first one we want to do is the horizontal distance. So cos 18 degrees equals horizontal distance over slope distance. The horizontal distance is the adjacent, so we're going with the cosine on that one. And cosine 18, and then we just multiply out the ratio quite simply, like cross multiply if you like. Imagine cos 18 is over 1, And so we get cos 18 equals, horizontal distance is equal to cosine 18 times 227.50, which is our slope distance. And that equals, well, 216.37. We'll just confirm that here with the calculator, just to check. So we just go cosine 18. Remember, you've got to be in degree mode. Don't forget to close the brackets, and then we've got to multiply by 227.5 equals, and that's 216.37. I've just the data is given to 2 decimal places, so I've rounded to 2 decimal places, so 216.37. I'm happy with that. Oh, except that you can't see the calculator there, so I'll just put it over there. There it is there. And you can see that I've done cosine 18, 227.5. Okay, all right, moving right along. So that's our horizontal. I've put that in red so that you can clearly identify the answer. Would make it really easy to mark. Ooh, I like easy marking. So let's have a look at the sine now, and that's 18 degrees is equal to delta h, difference in height, over the slope distance, and same deal really, delta h equals sine 18 degrees times 227.5, and oops, we'll just back the truck up there, and let's just check that with the calculator. So we can, with our calculator, we can just go up. We can just come back here like this, and delete that and change it to sine. And look at that, equals, there's your answer. Sine 18 is 70.30. Oh, very good. So we'll continue on from there. But that's not the answer that we want. Remember, the answer to part B is how high above mean sea level is peg B. So we've got peg A at 106.4. Then we add the instrument height, 1.8, that'll take us up to the instrument. Then I say apply the difference in height, because the difference in height can be either positive or negative. If we're looking up, it's positive. If we're looking down, it's negative. So apply the difference in height. So it has a sign. If it's up, it's positive. If it's down, it's negative. And then we take away the instrument or the target height. And I've tried to indicate this with the arrows there. And so that's a negative, and we add all that up, or we do that sum, so we can bring back the calculator just to check that we've got that right. You can never do too many checks. So 106.4 plus 1.8 plus 70.30 minus 2 equals, click that there, 176.50 AMSL, above mean sea level. And there you have it, the answer to the question. Bloody marvellous.